Okay, so today we're going to be doing 1.4, the method of elimination. So by the end of the lesson, you should be able to algebraically solve a linear system of equations using a method called elimination. Here are the steps that you have to take to apply the method of elimination. So they're there for your reference. Just go back to them, use them as a tool if you are having some difficulties. But I'm going to just go through some examples. Okay, so the first one should look very familiar to you because you've already algebraically solved using substitution. So this is just the same. You're given two linear equations, but this time you're being asked to solve using the method of elimination. So the very first thing you always want to do with the method of elimination is you want to get each equation into what we call ax plus by equals c form. So the x is first, the y is second, the equal sign next, and then any constants on the other side of the equal sign. So that's what we're going to do first. We're going to rearrange these. So I'm still going to call this 1, but it's just rearranged. So this is going to be 3x minus y equals 3. That's number 1. And then number 2, I'm going to bring the x in front of the y with the sign that's in front of it, okay? Because I'm not moving it across an equal sign, so it does not change sign. So this is minus 2x, and then the sign in front of the y was a plus. So that's plus y equals, and of course when I move that positive 2 over, it becomes negative 2. All right, I'm going to put a big old line here. And I'm just going to make sure that my x's are all lined up, that my y's are all lined up, and that my numbers are all lined up in columns. And that's the case. And then what I ask myself is, which variable could I eliminate at this point? And sometimes you can't eliminate right away, and we'll talk about that with the next example. But in this case, I could eliminate one of the variables without changing the equations by performing either addition or subtraction. In this case, if I add the negative y and the positive y, I eliminate the variable. If I subtract, I don't, right? So minus, say, 2 minus positive 2 is going to equal negative 4. But minus 2 plus positive 2, that's going to equal 0. And if I have a 0 coefficient in front of my variable, that means the whole thing, it's like 0 times y, which is just 0, right? I eliminate that whole variable. Okay, so that's the objective here, is to get a coefficient of 0 for one of our variables. And that happens here when my operation that I performed on every column is addition. So we're going to go ahead now and we're going to add 3 plus negative 2. Well, that's just x. And then minus y plus y is going to equal 0y. So I'm just going to write it like this, plus 0y. And then 3 plus negative 2 is 1. 0 times y is just 0. We don't even have to write it from the beginning, but if you want to, you can. So that's just x equals 1. And look at that. I've eliminated the y and I've solved for x. And I'm done. Now, the rest of the solution looks exactly like substitution. Now I'm just going to sub x equals 1 into either of my equations. I'm going to solve for y, and I'm going to do my check. Okay? So sub x equals 1. I don't know, it doesn't matter. I would say into 1. So this is going to be 3x minus y equals 3. And then 3 times 1 minus y equals 3. Just keep going here. And then 3 minus y equals 3. Minus y equals 3 minus 3. Let me bring that 3 over. Minus y equals 0, and believe it or not, when I divide or multiply 0 by a negative, it stays 0. 0 is neither positive or negative. Okay, so at this point I could say, so the point 1, 0 might be the solution, and check the point 1, 0. First equation was 3x minus, I have to make sure now I'm going back to the originals, 3x minus y minus 3 equals 0. And so when I put in 1 for x and 0 for y, let's see if left side equals right side. 3 minus 0 is 0. And left side equals right side. And if I repeat with the other original, y minus 2x plus 2 equals 0, then I get, when I sub in 0 here, 1 here, I get 0 minus 2 plus 2 equals 0, and 0 equals 0. So left side equals right side. Sorry guys, I'm having technical difficulties. But for that last question, you would just put a therefore statement in and say the solution to the linear system is 1, 0. Okay, let's try the next question. So what I want you to do here is I want you to try this. So pause the video right now. You try it. I'll do it in the meantime, and we'll see if you get the right answer. Okay, so the first thing we have to do, step 1, is to rearrange it into ax plus by equals c form. And so if I do that, the first one's already in that form, but the second one needs to be rearranged. So I'm going to rewrite the first one. X plus 2y equals 0. And I'm going to rewrite the second one as x minus y equals 3. You put a big old line underneath. You should have x's, y's, and numbers in a column. And you can see that I have 2 x's here. And so what you have to do is you have to ask yourself, what operation do I want to perform on this linear system that's going to eliminate that variable x? And I've chosen x to eliminate because the coefficient in front of the x is 1, right? There's an invisible 1 in front of both x's. So I know that when I subtract something that has the same coefficient, I'm going to eliminate it. So I am going to perform subtraction here, and I'm going to get 0x. And then this is tricky, and this is where many of you will make mistakes, so pay attention. 2 minus minus 1. Well, what's 2 minus minus 1? That would be 3. Okay, so this is plus, oopsie, just black here, plus 3y. And remember, I'm doing subtraction, so 0 minus 3 is minus 3. So I end up with 3y equals negative 3 and y equals negative 1. Okay, so the general rule for deciding whether or not you are going to add or subtract when you have the same coefficient, this is what I tell my students, S, S, S. If the signs are the same, you subtract. So I'll show you an example. 2 and 2. Of course, 2 minus 2 equals 0. But it also works for 2 and minus 2, because 2 minus minus 2 is the same as minus 2 minus minus 2 is the same as minus 2 plus 2, which does equal 0. Okay? So we want to make sure that we remember S, S, S. If the signs are the same, you subtract. If the signs are different, you add. Okay, so I'll just get rid of that because I need the space. So now we're just going to substitute y equals 1, negative 1, sorry, into the either equation. So I'm going to choose to substitute it into what I perceive to be the easier equation, which is number 1. So sub y equals negative 1 into 1, and I get x plus 2y equals 0 when I start off, and then I'm going to have x plus 2 times negative 1 equals 0, x minus 2 equals 0, x equals 2. So we've got the point 2, negative 1 as a possible solution. We're going to check the point 2, negative 1. And when we do that, we always go back to our originals. So it's going to be x plus 2y equals 0. So 2 plus 2 times negative 1 equals 0. So 2 minus 2 equals 0, and 0 equals 0. And of course that means that left side equals right side. And if I continue here with the second equation, which was x minus y plus minus 3, let me just double check, yeah. X minus y minus 3 equals 0. I'm going to put 2 in for x. This is where it gets tricky. It's minus y. So we're subtracting off our y, but our y is negative. So this is going to be 2 minus minus 1. And we always have to write, we can't have a minus minus beside each other. We either have to write it in brackets like this, or we change the minus minus to a plus. Okay, so this is really like 2 plus 1 minus 3 equals 0. 3 minus 3 equals 0, and 0 equals 0, so left side equals right side. And then I'll just go over here to say, therefore, the solution to the linear system is 2, negative 1. Okay, so those were pretty straightforward examples. Hopefully you got that solution. And we're going to go a step further now with a system that's slightly different. So the step is the same at the beginning. We want to rearrange it into ax plus by equals c form. So let's see. The 3x has to be on the left-hand side, so that's going to be minus 3x plus 4y equals negative 4. And the second one is going to be 2x minus 5y equals negative 9. Now, if we look at the coefficients of each set of variables, we have a minus 3 and a 2 here in front of this x. We have a 4 and a minus 5 in front of the pair of y's. And so we don't have any variables whose coefficients are the same, disregarding the sign. So we have a problem here because we know that by adding or subtracting either of these pairs, we're not going to eliminate the variable. So what we have to do first is we have to rewrite these equations in terms of an equivalent equation. Okay? And remember, we can create equivalent equations by multiplying each of the terms of the equation by a number. So here are our options here. If I multiply this equation by, say, 2, I get negative 6 here. And then below, I would have to multiply this equation by, goodness gracious, sorry, by 3 in order to get a 6 here. And then I would have negative 6 here, positive 6 here, and I could just add these columns in order to eliminate the x. On the other hand, I could have chosen to multiply this equation by 5 to get a 20 here, and I could have multiplied this by 4 in order to get negative 20 here, and then I could have added these equations and eliminated the y. So it's totally up to you how you approach this, as long as you rearrange it into you manipulate it so that they are equivalent equations. So I'm going to multiply this one by 2, and I'm going to multiply this one by 3. All right, so let's go ahead and do that. We're really creating equivalent equations, so I'm going to call this 3. And so this is going to be minus 6x plus 8y equals minus 8. Make sure you're multiplying every term by that number that you've chosen. It's a very common mistake that either only this term gets multiplied or the left-hand side gets multiplied, and you forget to do it to the right-hand side. So be careful about that, right? It's not equivalent unless you're multiplying everything by that number. Okay, then times 3, so you would get 6x minus 15y equals negative 27. All right, let's go ahead now, decide which operation we're performing, addition or subtraction, and I can see that my signs are different, so we're adding. So I'll just change, I'll write in plus, I'll add those, and I get 0x. When I add these, I get minus 7y, and when I add these, I get minus 35. Okay, so now I have a minus 7y. Be very careful about the sign in front, right? Minus 7y equals minus 35, and when I divide through by minus 7 on both sides, I end up with y equals 5. Okay, and then we're just going to substitute in. Doesn't matter which equation. Substitute y equals 5 into, does it really matter? I don't know, let's just go with 1. So I'm going to go minus 3x plus 4y equals minus 4. Minus 3x plus 4 times 5 equals minus 4. Minus 3x plus 20 equals minus 4. Minus 3x equals minus 4 minus 20. Keep on going here, and we end up with 8. By the time I divide through by minus 3 on both sides there. So, the possible solution, can you hear that in the background? That's laundry happening at my place. Okay, so the possible solution is 8, 5. Now we're going to check. Always remember to check the original equations to pick up any errors that you might have made in any of your manipulations along the way. So 4y equals 3x minus 4. And x is 8 and y is 5. So we're going to say 4 times 5 equals 3 times 8 minus 4. So 20 equals 24 minus 4. Well, I agree with that one. So left side equals right side. Let's check the other original. So 2x minus 5y plus 9 equals 0. So 2x minus 5y, was it minus 9 equals 0? Let me just double check. Hate to write it down wrong because then my check would be wrong. See, look at that, it's plus 9. All right, so that's 2 times 8 minus 5 times 5 plus 9 equals 0. So this is 16 minus 25 plus 9 equals 0. 16 minus 25 is minus 9, and minus 9 plus 9, of course, is equal to 0. All right, so therefore, the solution to the linear system is 8, 5. Okay, and the only other difficulty that you can run into is that it can get tricky with fractions. So you just have to be very good with multiplying and adding your fractions, etc. You might want to clear fractions if you can create equivalent equations without fractions, etc. So there are some strategies there. So, but really, the method is the same. Okay, good luck with your homework. Thanks for listening.